In the last video, we focused on the exterior angles of a polygon. This video will carry that one step further and now focus on the interior angles. But before we can go there, let's talk about that relationship that exists between the exterior angle and its adjacent interior angle. So if I were to start with any polygon, and I think to keep things simple, I'll start with a triangle. And I look at the interior angle and the exterior angle. The exterior angle is this guy here outside the triangle. The interior angle is going to be the one that's adjacent to that, but inside the triangle. And notice from the picture that those two lie on the same straight line. In other words, they form a linear pair, and they're supplementary. So the exterior and the adjacent interior angle always going to be supplementary. And that's a big idea that will help you as we navigate through working with interior and exterior angles. Now, we know that the sum of all of the measures of an exterior angle of any polygon is 360 degrees. And we're interested in finding out if there's a way that we can determine the sum of the measures of all interior angles of any polygon. So I'm going to start with the most basic of polygons, the triangle. And we know from our study of the study of triangles that the sum of the interior angles is always 180 degrees for a triangle. I'm going to move one step forward and look at a four-sided quadrilateral. And I'm going to, for a minute, consider the four-sided quadrilateral as actually being two triangles. If this triangle has 180 degrees in the sum of its angles, and the triangle on the right has 180 degrees in the sum of its interior angles, then the quadrilateral must have a sum of 180 plus 180, or 360. I can do the same thing for a pentagon, and it might be a regular pentagon, it might not be a regular pentagon, but I can divide that pentagon into three triangles, each of which has the sum of its interior angles equal to 180 degrees. So the sum of the interior angles in the pentagon is going to be 180 times 3, or in other words, 540. And I could continue to do this for all polygons of any number of sides, but what we're really interested in is generating a formula. So if our polygon has n sides, that means that we can form two less than that triangles. For instance, in the five-sided polygon, we formed three triangles. The four-sided polygon, we were able to form two triangles. And of course, the three-sided polygon, we were able to only form one triangle. So a polygon of n sides is going to have n subtract 2 triangles. And if each of those n subtract 2 triangles contain 180 degrees, I can multiply the number of triangles, n subtract 2, times 180 degrees in each triangle, and that's going to equal the sum of the interior angles. So it says formula for the sum of the measures of the interior angles. Well, sum is going to be equal to either 180 degrees times the number of sides subtract 2, or the number of triangles times 180 degrees. That's a big idea. That's a formula that you need to know. Hopefully, if you understand where it comes from by looking at the polygons, that should be an easy formula for you to memorize. All right, let's go look and see how we can use that to solve some problems. We're given this quadrilateral ABCD with the following angle measures. And they want us to find the number of degrees in the largest angle in this quadrilateral. First thing that you need to recognize is that when you draw a picture of quadrilateral ABCD, obviously it has 4 sides and 4 angles. When you go to letter your vertices, you can either letter around going clockwise, or you can letter your quadrilateral going counterclockwise. You may not zigzag around your quadrilateral. So if I go clockwise, angles A and C are opposite or across from each other, as are angles B and D. If I had lettered my quadrilateral counterclockwise, A and C would still be opposites, as would D and B. And that's kind of an important thing to know. All right, so now that we've paid some attention to that, I'm going to go label our angles. And because we're working with a four-sided polygon, I know that we can make two triangles times 180 degrees in each triangle. I know that the sum of the interior angles for this polygon has to be exactly 360 degrees. So I'm going to go write an equation that sets the sum of all the interior angles equal to 360 degrees. Notice that in this question, they did not describe whether we're working with interior angles or exterior angles. If it's not specified anywhere in the problem, it just says largest angle of this quadrilateral. If it's not specified, you need to understand that we're always working with interior angles. All right, so the first angle, angle A, 2x plus 20, plus the second angle, 3x subtract 30, plus the third angle, x plus 10, plus the fourth angle, 2x. All four of those angles together must have a sum that's equal to 360 degrees. All right, so if I go through now and combine my x's, I end up with 8 of those. Combining the constants, I end up with nothing. So 8 x's are equal to 360 degrees, which tells me that the value of each x must be equal to 45 degrees. Now, this question did not ask me to find the value of x. It wanted the number of degrees and the largest angle. So I'm going to go ahead and write down the measures of those angles. Measure of angle A is going to be 2 times x, or 2 times 45, plus 20, or 110 degrees. Measure of angle B is going to be 3 times 45, subtract 30, or 105 degrees. Measure of angle C is 4x. Sorry, measure of angle C is 45 plus 10. Let me go back and change that. Or 55 degrees. And the last angle, measure of angle D, is going to be 2 times 45 degrees, or 90. So to answer the question, largest angle is 110 degrees. All right, number 2 says to the nearest hundredth, find the measure of an interior angle of a regular 23gon. Well, I'm going to start out by finding the sum of the angles. So the sum of the angles is going to be, for a 23-sided polygon, it's going to create or form 21 triangles. Each of those 21 triangles contains 180 degrees. So when I multiply 21 times 180, when I multiply 21 times 180, I end up with 3,780. So I know now that if I add all those 23 angles together, I end up with 3,780 degrees. I want to find just the measure of one. So I'm going to take that sum, 3,780, and I'm going to divide it up equally amongst the 23 angles in that polygon. And it asks me to round this to the nearest hundredth. So I end up with about 164.348, and then a whole bunch of other stuff to the nearest hundredth. That's going to round to 164.35 degrees. All right, the last one says the sum of the measures of a polygon is 2,520 degrees. They want us to work backwards now and figure out how many sides the polygon has. The first thing that I'm going to do is I'm going to take that 2,520 degrees and I'm going to figure out how many triangles were used to make that. So I'm going to undo the multiplying by 180 by dividing by the 180. So when I divide the 2520 by the 180, I find out that this polygon had 14 triangles. And since the number of sides is always 2 more than the number of triangles, I know this number of sides must be 16. So I'm liking for that one, letter C. All right, what I want you to do with this, like always, summarize the key ideas and the important understandings. What's the information that's important, that's special, that I want you to take away from this video? And then once you've done that, see if you can use those key ideas and important understandings in order to solve the questions at the bottom of the page.